In this video, we're going to start looking at how we can use a reaction mechanism to write the rate law for an overall reaction. So what we need to recognize first is that not all steps in a reaction mechanism proceed at their same rate. And the rate of the overall reaction is going to be controlled by whichever step of its mechanism is slowest. The reaction as a whole cannot go faster than the slowest step of the reaction. So this slow step of our mechanism is known as the rate determining step or the rate limiting step. Of our reaction. Either terminology is fine. So what this means for us is that the rate law for the overall reaction is actually equivalent to the rate law for the slowest step, for the rate determining step. So if we look at a mechanism, we can use that to write our rate law. So let's say step 1 is A forms B, and that is our slow step. Step 2, A plus B forms C, and that is comparatively faster. And you will usually be given information like this where it literally just says slow and fast next to each step in your mechanism. So what we can do is we can write the rate law for each step. Each step in a mechanism is elementary, which means that we can write the rate law for that step. So the rate for step 1 is going to be equal to the rate constant for step 1 times the concentration of A, first order, since we just have one molecule of A, unimolecular step. For step 2, our rate law is going to be equal to a different value of K times A times B. So we can write the rate laws for each individual step. And our overall rate law is equivalent to the one for the slowest step. When the slow step is the first step, they're literally exactly the same. So I am careful to use the word equivalent up here because they're not always identical. They are always mathematically equivalent, but they're not always identical. But when the first step of your mechanism is the rate determining step, the rate law for your overall reaction is identical to the rate law for your slow step. So this is our overall rate law here. So when first step is slow, super easy, write the rate law for the first step, and that is the rate law for your overall reaction. We didn't even need to find the overall reaction here. We could have, we didn't, it's fine. When the slow step is not first, things get a little bit more complicated, but that is the topic of our next video.